Alright, this video is going to introduce the 6 trigonometric functions. So what are the 6 trig functions? Well, they have names. They're called sine, cosine, tangent, cotangent, secant, and cosecant. Right, and here's how they are defined. Right, so we've got some angle, and there's some point on your ray there, xy. Now if this point is xy, that means that this distance right here is x, and this distance right here is y. If we know this distance is x and this distance is y, we can actually find what the distance is from the origin out to this point. We're going to call that r. Right? We can actually find that distance because that's just the Pythagorean theorem, right? So we have r squared equals x squared plus y squared. Remember? Leg squared plus leg squared equals hypotenuse squared for a right triangle. So therefore r is equal to the square root of x squared plus y squared, which does not go to x plus y, so don't be doing that. Alright, so now we've got representations for all three of these lengths, x, y, and r. Here are how the 6 trig functions are defined. Alright, for the first one, sine, we're going to use the following notation. S-I-N, and then theta. You read this as the sine of theta. So sin theta, sine of theta. And that's defined to be the following ratio, y divided by r. We're just saying the sine of this angle is just this ratio of this triangle, y divided by r. Right? Then we're going to do cosine. So cosine would be cos theta. And you read that the cosine of theta. And that's going to be defined as x divided by r. Okay, this is just how they're defined to be. So really cosine, sine, tangent, all these 6 trig functions, they're really just ratios of sides here, right? Ratios of sides of a triangle. Tangent would be next. The notation we're going to use for tangent is tan theta. And that's defined to be y over x. So whatever this value is divided by this value, provided x does not equal 0. Because then it would be undefined. Right, so the next one is that I want to do is cosecant. So the notation we're going to use for cosecant is CSC of theta, and that's defined to be r divided by y, provided that y does not equal 0. And then let's do secant. So the notation for secant would be SEC of theta, and that's defined to be r divided by x, provided x does not equal 0. Right? And then cotangent. So the notation for cotangent is COT of theta, and that's defined to be x divided by y, provided y does not equal 0. Right, so there's the definition for all 6 of the trig functions. Right? And so make sure you understand these notations because we all want to make sure that we know what we're talking about. All right? Alright, find the values of the 6 trig functions if, here's your angle, right, and there's your point. Alright, so what do we need to find first? You know what the x value is, the y value is, you need to know what that r is. So r is equal to the square root of x squared plus y squared. So r equals 5. Everybody see that? So this value for r is 5. So here we go. Sine of theta. Sine was defined to be y divided by r, right? Y divided by r. So that would be negative 4/5, right? Cosine of theta is defined to be x divided by r, so that would be negative 3/5. Tangent of theta is defined to be y over x, and so that would be 4/3. Everybody see that? Because it would be negative 4 over negative 3. Right? Cosecant theta is defined to be r divided by y, and so that goes to negative 5/4. Yeah, these are just reciprocals. Sine theta and cosecant theta, they're just reciprocals of each other. We'll make that more formal later. Alright, so secant theta is r divided by x, so that would be negative 5/3. Yep, cosine and secant, they're reciprocals of each other as well. And tangent and cotangent are also reciprocals. Cotangent is defined to be x divided by y, and so in this case that'd be 3/4. Right? So once you know those first three, the other three follow pretty fast if we realize what is a reciprocal of what. But again, we'll formalize that up later. All right, so that's it. Those are the 6 trig functions. You're just finding ratios of sides of a triangle. That's all this is. So now, let's find the sine of 90 degrees. So in order to find the sine of 90 degrees, we need to know what r is, right? We know that x is 0, y is 1. What's r? Well, r is equal to the square root of 0 squared plus 1 squared. So r equals the square root of 1. So r is just 1 as well. So sine of 90 degrees, defined to be y over r, so you have 1 over 1. So the sine of 90 degrees is just 1. That would be true even if this wasn't the point 0, 1, wouldn't it? What if that was the point 0a, right? So what if we just, really quick down here, what if we said our point is 0a, right? Then r would equal the square root of 0 squared plus a squared, which equals the square root of a squared, which equals a. So r would be equal to a. And so then when you did, and again, this is the angle we're looking at, 90 degrees right here. Okay? So when you did the sine of 90 degrees, you would have a divided by a, which goes to 1. Everybody see that? So the sine of 90 degrees is always equal to the number 1. Always. Same idea with the cosine of 90 degrees. Cosine of 90 degrees would be x divided by r, and 0 divided by 1 would just be 0. So the cosine of 90 degrees is always 0. The sine of 90 degrees is always 1. And the tangent of 90 degrees, tangent's defined to be y over x, so 1 over 0. Therefore, tangent of 90 degrees is undefined. That's always going to be true. Sine of 90 degrees is always 1, the cosine of 90 degrees is always 0, and the tangent of 90 degrees is always undefined. Which then brings us to radians. So 90 degrees in radians is pi over 2. The sine of pi over 2 should be the same thing as the sine of 90 degrees because they represent the same angle, right? So this is equal to 1. The sine of pi over 2 is equal to 1. The cosine of pi over 2 is equal to 0, and the tangent of pi over 2 is undefined. Here we're just talking about it in degrees. Here we're talking about the angle in radians, right? But their trig functions should be the same value. The sine of 90 degrees is the same thing as sine of pi over 2 because 90 degrees and pi over 2 puts you at the same spot. All right, so now let's do the sine of 180 degrees. Right, so we'll take a point there. Let's just take the point -1, 0. We could take any point, it doesn't matter. But the x value would be something and the y value would always be 0. So therefore that implies then that r just go to 1. So the sine of 180 degrees would be y divided by r, which is just 0. So the sine of 180 degrees is always equal to 0. Whereas the cosine of 180 degrees, -1 divided by 1, right? Because it's x over r. So the cosine of 180 degrees is always -1. And then the tangent of 180 degrees is equal to, so you get y over x, and that goes to 0. So the tangent of 180 degrees is always 0. These values are never going to change for the sine of 90 degrees, cosine of 90 degrees, or the sine of 180 degrees, cosine of 180 degrees. These are always, we're finding their values right now, what they will always be. So what's 180 degrees in radians? All the way around the circle is 2 pi radians. So halfway around the circle would be pi radians. So the sine of pi also has to equal 0. And the cosine of pi has to equal -1. And the tangent of pi has to equal 0. You follow me? All right, so there's the definition for the 6 trig functions. Make note of the notation that's used. We have to have an angle. It's got to be sine of something. We never just write sine equals 1. You have to take the sine of something. SIN by itself, COS by itself, they don't mean anything. You have to be taking the sine of an angle. You have to be taking the cosine of an angle, right? So we have to have an angle in there, right? If you drop off the little theta sign or whatever angle you're playing with, like the 90 degrees we had a minute ago, if you don't have those in there, then it's not correct, all right? So please be careful, make note of the notation, and that's it, all right? All right, study well. Please let me know if you have any questions.